In this lab, we will continue with applying machine learning methods on the data for households in California. We will, in step 1, we collected, we read the data from the file, and in step 2, we performed exploratory data analysis to understand the data better and make ourselves comfortable and familiar with the data set. We looked at plotting interactive box plot for each variable in the data set using Plotly. Then we plotted histogram for each of the variables to see the distributions. Then we visualized the relationship between the geospatial attributes longitude and latitude with the response variable median house price. Then we identified all the missing values and filled them using an imputer from sklearn, then double checked if we still have those missing values. And then in step 3, we are performing feature engineering. So in firstly, we created 3 new variables: average rooms per household, average bedrooms per room, average population per household. Then we encoded the categorical variable ocean proximity using one-hot encoding. Then we splitted the data into training and test set using sklearn. And now in this task, we are continuing with the feature engineering by performing either a standard scalar or a robust scalar on both xtrain and xtest. So we will perform both of these scalar on xtrain and xtest, and then in the next step we will be plotting the graphs. In order to provide a standardized input to our machine learning, we need to perform the normalization of our dataset. This can be seen as a step to reduce the differences in scale that may arise from the existent features. First, we we perform standard scalar on both xtrain and and xtest. Standard scalar, let scalar equal standard scalar open and close bracket. So from sklearn.preprocessing, import standard scalar and then let scalar equal standard scalar open and close bracket. Then we fit and transform the training data. Let access train equal scalar.fit underscore transform of xtrain. Then transform test data using the fitted scalar. Let access test equal scalar.transform of xtest. Then we display access the train data and the scaled test data. We see that it is in the array form. Each of the rows are in array form. Then we look at the columns for the xtrain, and we have this, and we do not need to reorder, so we already removed this. And now we plot scaled households versus scaled population, plt.plot. So before that, we need to import matplotlib.pyplot. So import matplotlib.pyplot has plt. Then we plot scaled households versus scaled population, plt.plot of xtrain of 5th column and xtrain of 6th column, and using the dots. So we will put our dot. So fifth column is 0, 1, 2, 3, 4, 5 population, scaled population, and the sixth column is scaled households. And PLT title is scaled training data. So we have this. Then we will perform robust scalar on both xtrain and xtest from a scalar.preprocessing import robust scalar. Robust scalar is let scalar equal robust scalar open and close bracket fit and transform training data xrs train equal scalar dot fit underscore transform of xtrain transform test data using the fitted scalar xrs test equal scalar dot transform xtest display of XRS train and XRS test data. So we have the sets displayed. The scale set is in array form. Each row is in array. Then we plot scaled households versus scaled population. A plt.plot of XRS train fifth column and XRS train of sixth column and using the dots. The X label we will put has scaled population. The Y label has scaled households. plt.title of scaled training data. plt.show open and close bracket. So we can see that this graph that we get is very similar to the standard scalar graph. So the values are very close to each other.